So the other day I was playing Pokemon Sapphire, you know those old Pokemon games which you used to play on Game Boy or the Game Boy emulator simulator, whatever it was called for people who didn't own a physical Game Boy like me. And I was hit with this wave of nostalgia and it got me thinking if I could recreate something similar in Flutter. So upon doing some research, I came across this package called Bonfire, which actually allows you to create your custom RPGs, role-playing games in Flutter, which is a pretty cool thing to do. Hey guys, hope you're doing well. For those of you who don't know me, hi, my name is Sakina Abbas. I am the co founder and CEO of Reactory, which is a software house where we specialize in creating web applications and mobile applications. And alongside that, I'm also a Google developer expert for Flutter and Dart. And in today's video, you will be learning how you can create your very own RPG purely in Flutter using Bonfire. So without further ado, let's get started. If you search for it on pub.dev, you will come across a web page like this. As you can see, it comprises of some previews from some of their examples. So you can actually see the true capability of building an RPG with Bonfire. It also contains a link to their documentation. To help you get started, they have this really neat page where it shows that in order to get started, you just need to add Bonfire as a dependency in your pubspec.yaml. And then you need to wrap your widget inside a Bonfire widget, and you have to provide a map. Now, fun thing over here is that the map uses Tiled, which is a software where you can create your custom maps, and it also offers you a bunch of examples that you can download for free. So it's really handy for when you're actually pursuing a proper game development. You can create really fancy maps over here. Then it shows how you can create your player. This specific section goes through how you can make use of sprites and basically load them in your game in order to make your player work. So in today's video, we'll be learning how to create Dash Tales, which features Dash, our very own mascot for Flutter, as he goes through and navigates through this map in the attempt to collect some collectibles. And Dash also at the same time has to avoid certain obstacles, otherwise he might die. And in order to help Dash on his journey, we will also have this wizard who will be imparting his wisdom towards Dash that, hey, this is what you need to do, and this is what you don't need to do, and that's pretty much it. So let's get started and see what we need to do. So we have our pubspec.yaml, where as you can see, I've added Bonfire as a dependency. Then I've also added a bunch of assets, which I've added as imports in the pubspec.yaml. These are the assets that we'll be using in order to build our game. So as you can see, I've laid them out in folders, starting with tiled. As you can see within tiled, we have map.json, which is like the main file for the map. Then we have tileset.png and tileset.json. All three of the files are equally important, and I'll come to their specific use later down the line. Then we have player, where we have dash idle left. As you can see, it's basically a couple of frames, in fact tons of frames for a tiny dash, and this will be used for when we're actually trying to animate our dash. Then when it comes to the wizard, we have its assets loaded under NPC. In this case, we have just 2 frames, so these are the only 2 frames in which our wizard will be animating between. Then as far as our collectibles are concerned, so we have them laid out under items such as Dart, Firebase, Maps, UI Overflow, from which Dart, Firebase, Maps are the 3 collectibles that Dash needs to collect, and UI Overflow is something that Dash needs to avoid. Alright, as you can see, this is our main.dart file. Nothing fancy over here, but please don't forget to include widgets flutter binding.ensure initialized. Now let's head over to our Dash Tales game, which is a stateful widget, and it is implementing game listener for the reason that it is able to let us know for specific events that we want to listen for in order to show, let's say, game over pop-up, etc., etc. Then we have a game controller which we have initialized inside our init state method, and we've added a listener to this. Then we also have 2 booleans for game over and game 1. The method that we have is called change count live enemies, which if we comment out, it would give us an error because we do need to override it as part of extending the game listener. Although for our sake, for simplicity purposes, we don't need to provide it any implementation. Then we have update game, which is a method that is called periodically. And then we have our normal build method in which we are calculating tile size, which is very important. We've given it a default value of 32 at the top, but then we're recalculating it based on our screen size and screen width and height. And the reason that we've set it as a global variable on top is that we need to access this tile size in other files as well. Then we have our main widget called the Bonfire widget, to which we have assigned our game controller. And we've added the joystick configuration, which basically dictates how the player will be playing this game. Will they be doing it via a keyboard? Will they be doing it via a physical joystick? In our case, it is the keyboard config so that we can easily play using a normal standard keyboard. Then for map, we are passing it with tiled/map.json and giving it a size in the form of a 2D vector. Please make sure that you add a map.json file along with tileset.png and tileset.json, because if you don't include the other two files, even though we're not including them explicitly, if they are not there in your assets, this map will not render and you'll start getting errors because it's having references here and there to the different components of the map that need to be rendered on the map basically. And then finally, we have given it some lighting. You can feel free to skip it out if you want to. But in our case, we've given it such that it's a little bit darker. Now next up, we're going to start off with our dash player. For that, we're going to create a new file called dashplayer.dart, which will extend simple player, again coming from Bonfire, along with lighting and object collision. Why lighting? Because we want to provide our player with some light to it so that when it moves, the light moves with it, and object collision so that it can detect collisions, etc., etc. Now for the constructor, we need to provide it an animation in the form of sprite animations. For the animation, it's giving us an error for player sprite sheet, which we'll be creating up next. Don't worry about that. Size, we've already provided it. Position, we've already provided it in the form of a 2D vector in the constructor. Then we need to provide it with a life. It could be 50, it could be 100, it could be 200, it's up to you. And then we need to provide it a speed, which is basically the default speed of this player at which it needs to move, right? So over here, we've defined it a speed of tile size by 0.25, so 1/4 of a tile size would be its speed. Let's try to implement a method called setUpCollision. This basically explains the region with which, and if any other object's rectangle collides with, then it's considered a collision, right? So in our case, for instance, we're using collision area.rectangle in which we need to give it a size and we need to give it an alignment. So whatever size we give it, whenever the rectangle associated to the player comes into contact with another object, then that overlapping of rectangles would be considered as a collision, which will be useful for collecting the collectibles that I showed you in the demo earlier. Okay, another thing that we are using over here is value by tile size, which is a helper method that we are going to create at our end that will convert a certain value and calculate the relevant value with respect to the tile size. Now we could write this logic again and again, but in order to avoid redundancy and duplicacy, we're going to create a helper method that helps us do that. So we'll create a constant called tile size sprite sheet, which is 16, and whatever tile size we calculated with respect to the screen size earlier, we'll divide that by our sprite sheet tile size and multiply it by the value that we're giving it. So it's just a calculation of tile size such that it's dynamic with respect to the screen scaling up and down. Having done that, the next thing that we need to do is obviously create our player sprite sheet. For that, we'll create a player sprite sheet file under our utils folder where we created functions.dart, and we will import Bonfire as a package, and we'll import Bonfire here. So we'll create a normal class called player sprite sheet, and we will create a specific sprite animation for idle left. So what this means is that when the player, when dash is idle, that is you're not moving it with the arrow keys, and it's facing on the left direction, then how should it be animated? To this, we will provide a dash idle right.png, which I showed you earlier in the video. And we will be using sprite animation data.sequenced, which basically requires us to provide us config for amount, step time, texture size. Let's create another method called player animations and give it 4 different types of animations. So let's give it an idle left, idle right, run right, because horizontally is the only way that we'll be managing its sprites. So let's do that similar to how we did it for idle right above. So we'll copy the same thing that we did above, with the difference that we'll set the amount to 6, which basically means in what frequency, what should be the frequency of this animation happening over frames, and step time is basically the delay that needs to be there between two frames. And giving it a texture size of 16 by 16 2D vector. Having done that, now we need to add our player to the Bonfire widget by writing player dash player and giving it a position of 2 times tile size on the x-axis and 3 times tile size on the y-axis. So this would be the initial position of our dash player. Okay, so for those of you who don't know what sprite is, sprites are something that you will come across literally everywhere throughout game development. So in very easier terminology, the player, the enemies that you see are sprites, the collectibles that you see are sprites, the decoration or any other objects or the wizard that you saw were sprites, and even the dialogue that was happening between the wizard and the dash, that was a sprite animation as well. So sprite in essence basically takes a bitmap in the form of PNG preferably. Try to run it now. And here we go. We finally have our map working and our dash player running across the map. Pretty cool, huh? Now it is a tad bit dark, I do give you that. So let's quickly fix that by adding some light to our dash, to our cute little dash. So in the same way that we set up collision, let's try to set up lighting now and providing it some lighting config. So over here we need to provide it the radius, like to what extent should the lighting be stretched to, what the color of this lighting should be, and where should it be blurred, like how should the border be blurred. So let's try to set up all that and see how that goes. Awesome, that looks much better now. Now, as you can see, as dash is moving, the light is moving along with it, as if it's under a spotlight. Perfect, that's just what we wanted. Okay, time to add in our collectibles. We're gonna do that by creating a new directory called decoration under our lib folder. And inside that, we're gonna create a file for Dart key, which in essence is just a Dart logo that will be displayed as a collectible that Dash needs to collect. So we're gonna do that by creating a class called Dart collectible, extending it with game decoration, along with sensor so that we can detect any collisions with this specific component. Now, as you can see, similar to Dash player, in the constructor, we need to provide it with a sprite. So we're gonna refer to the dart underscore small.png located under items, and we're gonna call sprite.load. This is not an animated widget, so we're not gonna animate it, we're simply gonna load it. Then we need to provide it with a position as well as a size, similar to what we did with Dash player. Now we need to override this method called onContact because it was giving us an error, and this will be the method that is triggered whenever there's a collision of this specific component with any other component. So over here we're going to check if this component is an instance of Dash player, in which case we need to add this specific collectible to our Dash player's list of collectibles so that we can then remove it from the canvas and then display it on top of the screen. Let's try to do that next. All right. So let's add in a list of collectibles in the form of a string list in Dash Player, which will contain the list of all collectibles that Dash has collected so far. And to make our life easier, let's create a constant for every collectible, starting off with our Dart collectible. So let's create a constants file and create a constant for our Dart collectible so that we don't have to add it by using the raw string and then checking against the raw string, because then that could run into issues if we don't put in the right spelling. Having done that, let's quickly add it to our list of collectibles under our Dash Player, and let's register it as an object under Objects Builder in our World Map by Tiled. And provide it a position as well. Awesome. Now let's see how that goes. Okay, as we can see, it's not rendering. Let's try to figure out why that is. Let's head over to map.json, which is basically, it has listed down all the different references of different objects that this map needs to contain. And as we can see, when we control F on Dart, it is written as Dart key, but in our constants, we defined it as Dart. Now, this is a very important concept because if you mismatch over here, then our map would not know that this basically refers to this specific component. So the map knows it as Dart key, but our code knows it as Dart. So we need to just change this to Dart key, otherwise we would have to change our constants to Dart. And it's here, woohoo! However, it's not removing it from our scene. I wonder why that is. Okay, so what we need to do is we need to add in a method called remove from parent, which again is provided by Bonfire. What it does is that it removes that specific component from the scene, which is exactly what we want. And it's working perfectly fine. Now the last thing that we need to do is we need to display it on the top left corner of our screen. In order to do that, we will have to work with an interface. So let's quickly create a dash interface.dart file under our interface directory. And extend it with game interface. Now let's create a variable for a Dart key, which will be of type sprite, because this is what we need to render. And let's create the onLoad method. And now let's override this onLoad method where we need to initialize our Dart collectible with our sprite. So we're gonna call sprite.load items dart small.png. Make sure to add in the await keyword because it's an async method, and also add the async keyword beside the onload method. And finally return it with the super.onload method. And make sure to change the type of this method from future function to future void, because the super.onload is of type void. Now let's override this method called render, which is responsible for rendering any specific element on our canvas. And as you can see, it's already providing us access to the canvas. So all we need to do is write implementation for at which point do we need to render our Dart collectible on our screen. For that, let's create a method called draw collectible, which takes an object of type canvas. And over here, let's check whether the gameref.player, gameref again is something that is already provided by Bonfire, so you don't need to worry about that by yourself. We check that the player is not null, and we check whether this player is of type dash player because we need to access collectibles and it's not present under game player, which is typically the type of the player in itself. So we typecast it as dash player, we check whether it contains the Dart collectible, in which case we then call Dart collectible.render. We provide it with canvas and then we have to provide it a rectangle, like where exactly does it need to draw on the canvas. So we're going to do that by using rect.from ltwh, meaning left top width height, giving it a left of 100, so 100 from the left, 20 from the top, a width of 30 and a height of 35. Let's call this now and let's see how that goes. Hmm, that's strange. We did eat it up, but it did not show up on our screen. I wonder why that is. So I just realized that we missed adding this interface to our bonfire widget in the beginning. So let's do that. And hopefully it'll work now. Woohoo! It's working. That's awesome. Now similarly, let's try to add in our other collectibles such as Firebase and maps. You can add in as many collectibles as you want. We're just sticking with 3 for now. And then let's create a UI overflow as well. But this will not be a collectible. This will function slightly differently. Similar to Dart, let's create constants for Firebase, maps, as well as UI overflow under our constants file so that it's easier to manage. Under our Firebase file, we just change the name of the asset that we need to pass it. We replace the constant with the Firebase constant, and we follow the same procedure for maps. Okay, time for UI overflow. For UI overflow, we need it to function slightly differently because it's not a collectible. So what we're going to do is that we will be adding this attribute called damage because we want UI overflow to inflict damage whenever the player comes into contact with it. Next, we're going to remove all the logic from on contact. And over here, now we need to write code that basically inflicts damage from this component to the player. So we do that by typing in gameref.player.receive damage. We provide it with an enum, the damage, like how much damage it needs to inflict, as well as an identifier of 1. Then let's register our remaining collectibles as well as UI overflow as objects under objects builder and provide it their respective positions. Awesome, so it's eating the Dart collectible. Then we have the maps collectible, although it's not rendering in the top left corner like we wanted it to. And then it has eaten Firebase collectible as well, which again has not rendered. And when it comes into contact with UI overflow, nothing happens. So let's try to fix these two problems one at a time. So probably our remaining collectibles are not rendering because we didn't add them to our interface. So let's do that. In order to add them to our interface, let's quickly copy paste whatever we wrote for our Dart collectible and just increment it left by 40 so that we are having them horizontally laid out and not vertically. Also, we need to add their individual sprites and then later down render them as well. So the maps is showing up. Firebase is showing up, which is awesome. And Dart is also showing up. So all 3 of them are showing up. Woohoo, that's amazing. Congratulations, guys. You've come here so far. Now let's try to fix whatever issue we're having with our UI overflow. Now, While the UI overflow is inflicting damage on the player in itself is not receiving any damage. So let's try to override this method called receive damage, in which we will register that, hey, this player is allowed to receive damage. It's not immortal. And then we show damage, the damage that has been inflicted on the player. And we do that by doing show damage, which again is a method by Bonfire. It will show the damage that has been inflicted and will provide it our custom text style in which it needs to be shown. And then finally, we're going to call super.receive damage and pass it attacker, damage, and our identifier. So what we need to do next is override this method called update, which is called periodically, which means on timestamp 1, timestamp 2, timestamp 3, and so on and so forth. And it provides us with those specific timestamps as well. Similarly, we need to provide a logic that if the player is already dead, then we just return a return, and we just call super.update. Now let's see how that goes. Okay, so we did see that Dash got inflicted by damage by 100 popping up 2 times, but still that wasn't enough for the player to know that, okay, Dash has died now. So what we need to do is we need to show our own custom dialogue, of which we will call a game over dialogue, and it will appear whenever the player is dead. So over here, it's nothing Bonfire specific. We're just doing our custom Flutter coding here. Having done that, now it's time to implement our update game method. We will check if our player is dead, in which case we will show a game over dialog. Now please note that we're adding another condition for if show game over is false, and the reason we're doing that is because update game is a method that is called periodically irrespective of the state of the game, right? So if we don't do that, then and if we just simply call or show game over dialog, then it will keep showing up and up and up again and again and again and again. So in order to not make that happen, we need to check for it, set it to true, and then show our game over dialog so that it's shown only once, even if update game is called again and again. Now let's try to run it and see how it goes. And as you can see, it showed us a game over pop-up, although it was stacked on top of the screen. So let's set the column size to minimum so that everything is shrunk and it's all in the center. Similarly, let's try to create another pop-up for game 1 or congratulations, which will be similar to our game over except that it will have congratulations, play again. And we need to display it whenever Dash has collected all 3 collectibles. Inside our update game method, we need to add a check whether our player, which is a Dash player, has collectibles of length 3. Okay, collect start, collects map, and there we go. It's saying congratulations. Now, in order to fix that yellow squiggly line, we obviously need to wrap our widget with material. And yes, that should fix it. So we finally need to add in our wizard NPC, who will be helping Dash with his journey. In order to do that, let's quickly create a file called wizardnpc.dart. Extend it with game decoration, provide it a constructor similar to the way that we did for Dash player. But except we obviously need to use an NPC sprite sheet here, which let's create up next. So creating a file called npc sprite sheet, which in our case will just be using idle left because we don't have much actions associated to the wizard. And we'll just provide it with wizard idle left.png and give it a sprite animation sequenced with this specific configuration of amount 4 step time 0.01 and texture size 16 by 22. Let's add in the import for NPC sprite sheet to fix the issue. And finally add it as an object under objects builder in your root widget. Aha, we finally see our wizard. Woohoo, perfect. Now, kind of like the last thing that we need to add in is the dialogues, right? So the dialogue happening between Dash and our wizard. In order to do that, we need to implement this method called cComponent under its update. First, we need to check obviously if the player is not null. And then we need to pass it the reference of gameref.player. So whenever this player comes in close contact with our wizard, then something needs to be triggered. In our case, a dialogue needs to be initiated. So the first thing first that we need to do is obviously make our player idle. So irrespective of whether you're moving it with with the arrows on your keypad, at this point while the dialogue is being performed, your player needs to be in idle position. We also need to add in the radius for this observation, in which case we're going to set it to 2 times the tile size, which is the distance between the player and the wizard, the minimum distance required. Now we need to create a method for show conversation, which we'll write as show introduction. And over here we're gonna write talk dialog.show, which kind of like works similar to how we do dialog.show. So we're gonna do talk dialog.show, which again is something provided by Bonfire. You don't need to worry about its intricacies. Just provide it with a context and add in a bunch of children of type say, in which you need to provide a text in the form of a text span, like what text needs to be rendered, who is it delivered by, which person, what sprite animation is being followed here, and in which direction is the specific person aligned. So over here, we're gonna create a custom sprite animation widget file so that it takes our animation and it sizes up according to the size that we want. Again, we could write this code, duplicate it wherever we need it, but in order to avoid that and the redundancy it's causing, let's just create a helper widget that helps us do that. It just takes this sprite animation and it converts it into a widget for us. Now let's call this show introduction method here. Let's add a logical keyboard key to next, which is basically what keys should be allowed that when you press them, it skips on towards the next part of the conversation. Let's try to add in other pieces of the conversations. So as you can see, the conversation is alternating between the wizard and Dash, in the sense that the wizard is on the right, Dash is on the left. So there you have it. You finally created your very own custom RPG with Flutter using just Bonfire. In order to get more hands-on on Bonfire and to explore it in further detail, please feel free to check out the official documentation of Bonfire, where you will find loads and loads of information on helpful subjects such as player, enemy, NPC, lighting, decoration, pathfinding, which could be specifically very useful for implementing, I don't know, game tutorials. Like, this is where you need to go, as you can see over here. It also has really useful examples laid out for you, so feel free to check them out, and some of its code is actually available on GitHub. So feel free to clone the repo, play it around by yourself, and basically just have fun. If you like this video, please feel free to let me know in the comments below. I'd really appreciate it. And if you're interested in knowing the performance side of things of working with Bonfire with Flutter, then also please feel free to let me know in the comments below. We might actually create a video where we analyze the performance of this RPG game using DevTools. And I'll see you again next time. Take care and bye bye.